What's up, YouTube? It's your boy JOHHABRAHAM. We back with inorganic. Oh shit, that's gonna be a long way. Inorganic is gonna be a long way. One hour, 45 minutes, 30, 30 minutes, 15 minutes. Dude, I gotta wash my hands. It's fucking weird. Just a minute, gang. Just a minute. It's not clean. Fuck. Where did I write the last part? I gotta watch this. Just a minute. How many minutes has it been? It's already 7 minutes. Okay, I just looked at the an Adult Swim animation, a new series that's coming up called President Curtis. That's gonna be cool. Gonna be cool. Yo. So the last part I wrote was speciation diagram with nomenclature of hydrides. They ask a question if aluminum 3 plus ion precipitator dissolve and if it precipitation pH gets lower. So lower the precipitation, more likely the metal cation can precipitate. Metals dissolve in water and depending on the acidity they precipitate. This is not the right direction. Metals do not dissolve as metals in this context. The species already considered is not solid metal. Metal ions in water undergo hydrolysis. This makes the solution more acidic. Then precipitation depends on the pH. As pH increases, The key trend, important correction. Higher charge density metal ions hydrolyze water strongly, forming OH containing species easily precipitate at lower temperature, lower pHs. So more acidic metal ion, easier precipitation at lower pH. I gotta charge my pencil. Just a minute. It was all yellow. Higher charge density metal ions hydrolyze water. Can I still write with the pencil being charged? No. That's so Apple. Why won't you do this? Why won't you? PKB equal, okay. If a mint is not stable, it reacts with water. So more charged dense metal ions. Lower charge density metal ions, weak hydrolysis, stay dissolved until basic conditions. Metal cations hydrolyze water to different extents depending on their charge density. Strongly hydrolyzing metal ions form hydroxide precipitates at lower pH, whereas weakly hydrolyzing ions remain soluble until high pH. Precipitation by category. Very strongly, very small white box. Exothermic dangerous, only stable in very concentrated acids. At almost any practical pH forms hydroxide oxide precipitate. Very strongly. No predominance diagrams for H2O. Cannot exist in water as a cation. Reacts completely with water. Example C4+. Exceptions: oxofolic cations extend to stay in the solution. Oxocations have larger radius, smaller plus charge, less acidic. Example V5+. Forms vanadol cation. Yo, I don't know too much about vanadol though. I'm curious on my screen time. Why am I curious right now? I don't know. I feel like screen time is so bad. 5 hours, 4 hours. Last week, last week was pretty low. What? Oh, maybe on this phone, okay. Where's books? The page is about classifying metal ions on how easily they form hydroxide peroxides. This controls how metal ions behave differently in water because of charge density. This controls how strongly they hydrolyze water, how acidic the solution becomes, what pH they form insoluble hydroxides, what categories mean non-acidic, feebly acidic, weakly acidic, moderately acidic, anions as bases. Well, what did I just do? Predicting pKs. pKb equals, if neglecting En electronegativity for simple anions, not the oxo anions, example PO2 minus, no value of R predict with neighbors. Selenium is 184 picometer, tellurium is 207, 23 picometer difference. 230 picometer is the radius. pKb equals 29 minus 1200. Where do you get those values though? This page is about how anions behave by bases in water and how that controls pH and basicity strength. Core idea. Anions in water do this. XY minus plus H2O gives H. XY minus 1 plus OH minus. Yeah, one electron pair is being replaced by hydrogen. Or one electron. Yeah, electron pair is shared between hydrogen and the metal or anion. Highly charged anions can accept multiple protons step by step until you reach a neutral acidic form. More negative charge, more proton grabbing ability, stronger base. Classification of anions. This is what example art is. Neutral, conjugate bases of strong acids, no hydrolysis, no hydroxide formation, weak bases, strong bases. Highly charged anions strongly attract H plus from water. Very strong base. Immediately produce hydroxide. Okay. Production of hydroxide is linked with the highly negatively charged anions. More negative charge, stronger attraction of H+. Stability of conjugate acid. Connection of pKb, just like acids use pKb. pKa, pKb equals minus log of pKb. Smaller pKb, stronger base. Larger pKb, weaker base. Yeah, I need to remember that. Trends in basicity. Non-reactive at the edges, outside plus bottom. Noble gases. Further up into centers, more reactive order. O2 minus, SN4. Wait. O2 minus SN. Where's SN? Where's SN? SN. TE. C4 plus, okay. Why you go like that though? Yeah. By basicity, O2 minus ST4. No value given. Estimate R. This page is showing a rule of thumb model of estimate basic strength of K simple anions by charge density Z squared by R. What the formula means. It's an empirical trend equation, not a fundamental law. Based on where often the class have constructed a partial PTE of a previous inorganic chemistry students. Okay, new elements are currently being created in part of the goal. New elements are currently being created in part of being the goal of extending the periodic table to see whether it continues the familiar pattern. If the pattern continues as yet of unknown period H should include a new block of elements. How many elements wide should this block be? Okay, I remember somewhat. Which essential in your diet is used in electron transfer processes? Copper metal or copper ion? I think it's copper ion, right? French fries are commonly said to be high in sodium. In which form is sodium found in French fries? Na, gas, solid, Na plus, copper 2. Redox active species in the solution can reversibly gain /lose electrons, so it participates in electron transfer proteins. Example, respiratory enzymes. It is also a bioavailable form of copper in the body. Okay. If your French fries burst into flames after adding sodium, which form of sodium has been added? Solid. Write the balanced half equation reaction of the conversion of sodium salts. Sodium chloride, not elemental sodium. It's a sodium solid. Metallic sodium reacts violently with water, moisture, producing heat and hydrogen gas, which can ignite. Oxidation of sodium metal. Write the characteristic valence electron configuration of the following ions. Is this normal electron configuration, but just considering the charge? Like if negative, add the number of negative charge with the characteristic valence electron configuration listed first are found in the species. 18 questions, okay. The characteristic valence electron configuration listed first are found in which of the species listed afterwards? These questions seems pretty reasonable type of questions. I don't know if it's inorganic at this point. $30 minutes. I need to wash my hands though. Put each of the following series of cations in the order of increasing size. Covalent radius of sodium is 166 picometers. Step between radius type equals 60 picometers. We assume the standard trend. Radius of covalent cation, covalent, van der Waals, anion. Van der Waals radius of sodium, one step larger than covalent. Van der Waals, anion. Okay, anion is the highest, cation is the lowest, cation, covalent, van der Waals, anion. Okay. Give the following pairs of atoms that are next to each other in the periodic table. Identify the pair in each set that are most nearly identical in size. Given the following pairs of atoms that are next to each other in the periodic table, identify the pair in each set that are most nearly identical in size. Uh-huh. 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 All are halogens, same charge, so size follow the group trend. Given the following pairs of atoms that are next to each other in the periodic table, identify the pairs in each set that are most identical in size. Fill in each blank with one of the following words: increase, decrease, or positive. The acidity of a cation as its charge increases. Acidity of a cation increases because the positive charge of the cation attracts the oxygen end of the water molecule. Water molecule. The basicity of an anion as its charge increases. The basicity of an anion dash as its charge increases because the basicity of an anion increases because the acidity of a cation decreases as the radius increases because the charge of the cation is further. You have found new 3 elements. The elements that are diagonal or have pure shielding effects versus lanthanide contraction can end up similar in size. Lithium was Berlin, different period trend, noticeable difference. Manganese versus iron, adjacent transition metal, different, small difference. Nd versus PM, lanthanide is very similar due to the smooth contraction. What the fuck is this? You have found 3 new elements which are in the name of the honor of your classmate Cochranium, Nogium, and Romium. In the quantitative analysis laboratory, you titrate their cations in order to determine the pK values. CC cation plus 12, Ng cation minus 8, and RO cation plus 3. Which of these 3 cations is more acidic, most acidic? CC, right? Which one is the least acidic? I guess Ng. Assign each cation to its acidic category. Assign 3 or 4 unlabeled predominance diagrams shown below to the appropriate new elements. Tell how you can dissolve oxide precipitate shown in first diagram. The halides, aluminum bromide, calcium bromide, PCl. Name each of the following salts containing oxo anions. 100? 100. What? I just saw 10 points, so there's 10 questions. Acidity of the cation increases as its charge increases. Yeah, because the positive charge of the cation attracts the oxygen end of the molecule, but the basicity of the anion increases. That was right. Both were right because the negative charge of the anion. The acidity of a cation decreases as its radius increases. Okay, because the charge of the cation is in further away from the oxygen atom of the water molecule. The acidity of the cation increases as its electronegativity increases. When this happens, the covalency of the cation-oxygen bond increases, which allows more electrons to flow from oxygen atom to the metal atom. This one, how is the Ng cation having minus 8 charge? Then it's an anion. Whoa. I got 15 more minutes. Okay. Whoa, whoa, whoa. Yep. Lord, where is this water going? I'm pouring water. It's up here. Okay, okay, okay. 1, 2, 3. Lock in, brother. Lock in, brother. I gotta lock in. So you must trust the charge, not the word cation. How to interpret the three species? Extremely high positive charge, very strong acid, anion, basic, not acidic, weak, moderate. Okay. Answer conceptually: most acidic, high positive charge; least acidic, most negative. Categories: very strong acidic, highly hydrolysis, precipitates easily, moderately acidic. So if it's very strongly acidic, this one, right? No, no, no. Now on the unlabeled predominance diagram, there's 4 type the first one having smaller cation space with large space for oxide, followed by the next one with a large cation space and a small then there's equal for the cation and the oxide. Ugh. My spelling is wrong. This is a matching a species to a predominance diagram based on the charge density, hydrolysis strength, size of the hydroxide-oxide region problem. First, understand what each diagram shape means. You described 4 diagrams. Diagram 1, small cation region, large oxide precipitate region. You describe 4 diagram and small cation region, large, meaning very strong hydrolysis, very acidic cation precipitates. Okay, large cation region, small oxide region, cation stable over wide range pH. That's where. Ignore all the acid diagrams, okay? What? I thought. Tell me how you can dissolve the oxide precipitate shown in the first diagram. phosphorylate transfer agent, not the methylating agent. Parthion is an organophosphate, not a phosphide derivative. Dimethyl sulfate hydrolysis is toxic. It's not related to sustaining life. Tetraethyl pyrophosphate is a pesticide. Anisole synthesis is not its function. Phosphate groups commonly act as ligands in bioinorganic and catalytic systems. Hemoglobin contains iron, not cobalt. Inorganic esters have major industrial and biochemical applications, example ATP and phosphates. Vitamin B12 contains cobalt 3 plus, cobalt plus, not manganese. Yellow boy is mainly iron hydroxide, iron oxyhydroxide, not aluminium. Aluminium. Nutrient elements can become pollutants at high concentrations. Eutrophication. Eutrophication. The two does not react with water. The two that does not react with water are CBR4. Oh, I think that's the one with the coordination number. I see. B. In acidic solution. I don't know if it's acidic solution gonna change anything, but you know what I'm saying. They do not react because CBR is sterically protected with no accessible low-energy orbitals for the nucleophilic attack, and PCl5 is kinetically stabilized, limited accessibility, and requires specific conditions for the full hydrolysis, preventing effective water attack. Okay, I thought it has something to do with the coordination number. Write the chemical formula of each of the following oxo acids in the Chinese. Sketch the speciation diagram of ASO3 minus anion over the pH range of 0 to 14 and label each of the predominance region with the respective protonated form. Draw in the boundary lines and write the pH values of the boundaries in this graph. Our radius of arsenic cation is 72 picometer. 1 hour. Okay. And over pH range of 0 to 14, label each predominance region with the respective protonated form. Draw in the boundary lines and XP. Strong acid analogous to sulfuric acid, high oxidation state. Arsenious acid. H3ASO3, acidic category, weak acid, lower oxidation state, more covalent, less oxygen-based stabilization. Selenous acid, H2SCO3, acidity category, moderate to weak acid. Permanganic acid. Okay, YouTube, I'm gonna end the stream. I got one more thing to do. Peace out.